One of the main reasons that I believe in God is the idea of the balanced universe. This is the idea that the fundamental nature of the universe, the way it's set up, is just right for life. In such a way that it's more well set up for life, more well balanced than is reasonably acceptable if the universe had come into existence by chance. And I'm hoping that I'll, in the next 10 minutes or so, be able to explain that and illustrate that, at least in enough of a way to make you interested in this as an area. So it's the idea, really, of the Goldilocks Principle. Some things have to be just right. They can't be too hot. They can't be too cold. They have to be just right. And the universe is one of those things that it's set up. There's so many things in the universe that are set up to be just right for life so that we can live in this universe. To sort of demonstrate this, here's the Earth and the Sun. The Earth is just the right distance from the Sun so that we're not scorched by it, we're not too hot, but we're not so far away that it's too cold for us to live. If we were closer to the Sun, then the Earth would be too hot for life, and we wouldn't be able to live on it. If it was much further away, it would be too cold, and we wouldn't be able to live on it. But it's just perfectly positioned to be right. Now, there is an acceptance in that. There's a band, really, a sort of acceptance window where we could be, where we'd have the right conditions for life. And we don't really want to get bogged down in exactly what that band is like in terms of how big it is. But needless to say, we can't be too close and we can't be too far away. And on top of that, we have to stay the right distance away. We have to keep within this window, this Goldilocks zone, throughout the duration of our orbit, in order for us to not get too hot and not get too cold throughout the year. And this brings us to the sort of idea that the fundamental laws of the universe, not just sort of the little things like how far away are the Earth and Sun, but the fundamental laws of the universe are set up just right so that we can have life. What do I mean by this? Well, what I want to emphasize here is that the Earth orbits the Sun in a very stable way. And the reason that the Earth orbits the Sun is because of gravity. Gravity holds the Earth in place, effectively. And the law that describes how gravity affects two objects is this. This is Newton's law of gravity. So any two objects with mass m1 and m2 will feel a force that is inversely proportional to the square of the distance between them, the inverse square law. I promise that's the only equation that there will be in this talk. But I really want to emphasize how important that inverse square law is. That allows us to have this nice stable orbit. If it was something else, if it was an inverse cube law, so r cubed, if it was just over r, if it was an exponent of some kind, something weird and complicated, then we wouldn't have a stable orbit. We'd have a chaotic orbit, and we'd either fly into the Sun or we'd fly off into space, where we then couldn't live. Either way, you couldn't have life on Earth. In fact, you'd probably fly first into the Sun and then out into space. In any case, you can't have life. Obviously, that's bad. But the universe is, as we can see, set up just right for life. We have this nice, stable orbit. Now, another example we can go from the very, very big, so the sort of solar system scale, down to the very, very small. And I want to spend some time thinking about atoms, specifically protons and electrons. So, when we think of an atom, this might be what pops into your mind, this sort of blob in the middle, and it's got stuff that flies around it. So the nucleus is in the middle, the electrons fly around it. And that's not a bad idea, I suppose. The very simplest atom that exists in the universe, and the most abundant, is hydrogen. So this is what a hydrogen atom looks like. It's just a proton in the middle, that's the nucleus, a positive proton, a negative electron, and the electron goes around. Now, the really important thing about this is that the proton and the electron have opposite but balanced charges. So with gravity, any two objects with mass will attract. With electrostatics, which is what charges are about, they have to be opposites. A positive and a negative will attract, a positive and a positive will repel, a negative and a negative will repel. So they have to be positive and negative to attract. The important thing about this is that a hydrogen atom, as a whole, has no overall charge. It has the negative part from the electron, the positive from the proton. They perfectly balance out and cancel out to make zero overall charge. Now, why is that useful? Well, this is really useful for the formation of stars. The way that stars form is huge clouds of hydrogen gas in space are drawn together by gravity, because they all have mass. And because they have mass, they're attracted to each other, and they form these big, dense clumps, and more gets drawn in, and that squeezes the ones in the middle, and they get hotter because they're rubbing together and so on, until they get hot enough to turn into a star. And that's great. But what if the proton and the electron weren't perfectly balanced in charge? Well, then all of your hydrogen atoms would have a slight charge, and that slight charge would then cause them to all repel each other. If they're all slightly positively charged, they push away from each other. And there's a point at which they're pushing each other apart more than gravity is pulling them in. And we can calculate when that is, and that's the limit where we can no longer have stars by this mechanism. And for that to happen, the charge of the proton and the electron has to be balanced to 1 part in 10 to the 17. Otherwise, you can't have stars. Now, 1 in 10 to the 17, that's 10 to the 17 is an odd number, it's a big number. What is that number? That's what it looks like written out in full. It's a 1 with 17 zeros after it. It's a huge number. In fact, it's so huge I can't really wrap my head around it. You can appreciate that it's very, very well balanced, but exactly how well balanced it is a little tricky. So let me try and illustrate it. Let's say we're trying to create a universe, and we're setting it all up. We're setting up all the different laws that will dictate how that universe works. And we're setting up what the charge of the proton and electron will be. And this is our scale. We've got a nice scale, and we can put on it where we want things to be. So firstly, we're going to place the charge of an electron. It's negative. We've gone for that, same as this universe. So now we need to balance that with the charge of the proton. So it has to be somewhere over here. But where? How much leeway do we have with our positioning? What is 1 part in 10 to the 17 on this scale? Are either of these options suitable? I think you can tell that only one of those would really be viable at all. But just to illustrate things, I've actually marked in vibrant green the area, or the window, the band that is acceptable, that Goldilocks zone, for the charge of the proton. Now, you may be wondering why you can't see it, and the reason you can't see it is because it's absolutely tiny. It's smaller than the width of a nucleus of an atom, and that's why you can't see it. It's so small, so incredibly narrow, it has to be that well balanced, you can't see it, at least on this scale. So let's try and change our scale. At what point, how big would you have to make this slider, this scale that we've got, so that you can see where the charge of the proton has to be? But what if we made it sort of the size of the orbit of the Earth around the Sun? Would you then be able to see it? If you were on Earth and this slider was sort of stretching from Earth all the way to the Sun, would you be able to see the acceptance window where you could have the charge of a proton? Well, even on this scale, it would still be only 1 micron across. 1,000th of a millimeter would be coloured in green on the scale that stretches all the way from the Earth to the Sun. That is how remarkably well balanced the charge of the electron and the charge of the proton is. And if you think about how they have that charge, that's remarkable as well. But we don't really have time to dwell on all these things. And there are loads of other examples that we could have thought of. Sticking with protons and electrons and their charge balance, it's not just stars formation that we could have thought of. We could have thought about weak interaction. That's gravity and the electrostatic force are fundamental forces. Weak interaction is another one. That requires the charge of the proton and electron to be perfectly balanced so that charge can be conserved throughout the interaction. A bit wordy, but fundamentally this is how stars burn, and without them being perfectly balanced, you wouldn't be able to do this. You wouldn't be able to have stars burning. We can think about chemistry. We could have thought about how fundamentally chemistry is about how atoms interact with each other. If they all had a slight charge, then they definitely wouldn't interact in the way they do now. Similarly, biochemistry, that's how atoms and molecules within your cells, within your body, interact with each other. Again, if everything had a slight charge, that would be all over the place. But there are other examples of this balance throughout the laws of the universe. So I pointed out the law of gravity before. We could have looked at all sorts of other ones. We could have thought about electrostatics. We could have thought about all sorts of laws. They're all perfectly set up to have an interesting functional universe that isn't, just uniform energy spread throughout the entirety of it, or just one dense clump of matter in the middle, which is what you get most of the time if you randomly set up laws. The fact that we have life within it is incredibly nuanced. And we could have thought about the strength of the fundamental forces. We could have thought about the range of these fundamental forces. So both of those have to be perfectly right for things to work. And we thought about charge. We could have thought about the mass of particles within this universe. There are so many examples we could have thought of how this universe is just so well set up for life within it. And this really sort of is where I want to sort of wrap everything up and conclude by pointing out the obvious thing I've been saying all along, that the fundamental laws of the universe are extremely well balanced to allow for life. Now, I have this picture here, you can see there, of some stones balanced on each other. Now, let's just say you were walking along and you saw a pile of stones. So you saw, say, 2 stones, one balanced on top of the other. If you saw just 2, you'd probably think a stone has fallen on another stone here, and they're balanced, but that's not too unusual, and you wouldn't really think anything of it. If it was 3 stones tall, maybe you're starting to think, okay, this probably didn't happen by chance. When it's that tall, that picture there, if you look at that and think that that happened by chance, well, I don't know, maybe it did, but it looks a lot like someone put it there that way. What if that pile was, I don't know, 50 stones tall, 50 meters tall, and every single stone was perfectly balanced, and if you moved any one of those stones by a fraction of an inch, by the tiniest amount, the whole thing would collapse? Would you say, ah yes, that happened by chance? Or would you say, that was made, that was designed that way, that was put together deliberately? This is how it is with the universe. The universe is, the fundamental laws of the universe are so well balanced to allow for life. It's more than is reasonable for anything that you could say is an accident. And if it's not accidental, then that implies that the universe has had a creator. Something has deliberately made the universe as it is and set it up to be just right for life. And that creator is God. And that is how the balanced universe demonstrates that there is a God. Thank you.